The long explanation on the even is look at like the cosine of, let's just pick pi over 4. What's the cosine at pi over 4? 1. Yeah. Remember, over 4 has the same ones. It's root 2 over 2 and root 2 over 2. So that's the coordinate point there, right? So the cosine would be a positive root 2 over 2, okay? Now what if I said what's the cosine at negative pi over 4? Remember, negative goes the other direction. What's the coordinate point there? It's root 2 over 2 and then negative root 2 over 2, right? So the cosine, whether the angle is positive or negative, doesn't change sign. If I asked about sine, it would change from positive to negative. If I did tangent, one would be positive, one would be negative, right? And then the reciprocal functions match. So the rule on cosine is the cosine of a positive angle is the same as the cosine of that negative angle. They would both be positive or they'd both be negative. It just doesn't change, where the other functions do. The important thing is we're not going to work with values in any way today and tomorrow. It's all substitution. So what you need to do is train yourself to look for certain things. When you see things like sine squared or cosine squared or tangent squared or secant squared or cotangent squared, cosecant squared with 1, add 1, subtract 1, whatever it is, then you're going to go straight to your Pythagorean identities. When you see something that has a negative on the angle, you're going to go straight to your even odd identities. When you see pi over 2 minus an angle, you're going to go straight to your cofunction identities. And we're going to try to substitute things out using them. Yeah, u is just an angle. So it could be x, it could be theta, it could be, they could plug in any kind of value that they want there. Sometimes you see alpha, sometimes you see beta. It's just an angle. Okay, so the goal of simplifying these expressions is to use substitution to simplify it as much as we possibly can. So if you have something that's like a sum, you want to get it down to one term, you're going to try to find a least common denominator and get it to one term. If you see something that has multiple terms on one side, you're going to try to simplify it as much as you can. Usually we simplify it down to sines and cosines, okay, but not all the time. All right, so this is it. That's basically what you're going to see the entire time. It's just going to say simplify. Okay, sometimes it gives you a hint like factor, which you'll see in a moment. But really what we're going to do is just look at this expression. I'm going to actually... Go ahead, Sophia. So again, we took that expression, we rearranged it so that it equaled what was on my question, which is that cosine squared x minus 1. And then that equaled negative sine squared x, so we put it in. Because they are the same trig function, I can actually just multiply it, combine it into 1, and it would be negative sine cubed x. Okay, so now go to 2. What do you see here? 2 cosecants. So if I take out cosecant, that means this gets divided by it and this gets divided by it. This would go away. I'd get cosine squared x minus 1. There's my squared and my 1 again. So I would go back to my reference sheet that says sine squared x plus cosine squared x equals 1. I'd want to rearrange it so the cosine minus 1 was on one side. So I would subtract again.
How do you choose which one you pick?
It should like which of those. As soon as you see cosine, excuse me, cosine squared and 1, I go to the one that has a cosine and a 1. If it had said cosecant, then I'd go to that one. If it had said tangent, then I'd go to that one. So this is the same moving around because I had the same result, right? So minus sine squared x. Cosine squared x minus 1 would equal negative sine squared x. So I move the 1 on the side with the cosine, I move the sine with the other side, which means I can again replace cosine squared x minus 1 with negative sine squared x. Now what's different this time is that those are not the same trig functions, right? What can I do with cosecant? It's not squared, so I'm not looking at my Pythagorean identities, right? It doesn't have a negative x, so I'm not looking at my even or odd. It doesn't have a pi over 2 minus theta, so I'm not looking at my cofunctions. Say it again, Ben. So it doesn't have a negative on the x. I don't want to use the negatives. If there was a negative on the angle, then I'm going to look at the cofunctions. This is just straight up cosecant, right? So cosecant can be rewritten as 1 over sine of x times negative sine squared x. Can I simplify that further? What if I put this over 1? This is multiplication, right? What can I do? You can cross out one of the signs. So I'd get 1 times negative sine of x, which is negative sine of x, over 1 times 1. And it's just negative sine of x.
So why couldn't you use the odd even identity thing?
So you can use it on, you can't when it's squared.
Oh.
So usually those, the negative will be on the actual variable that represents the angle. So if it had said sine of negative x, then I would go to my odd functions. All right, Helen and I and folks from home are going to continue to work a little bit on these questions. I will continue tomorrow, like we won't work all the way through. We will continue tomorrow. But, all right, so look at 3. It says secant of theta, cotangent of theta, and sine of theta. Oh, wait, hang on, I froze. So there's no negatives on the angles. There's no squared, so I'm not going Pythagorean identity. There's no pi over 2 minus theta, which means the only thing left for me is the reciprocal functions. Which reciprocal functions do you see here? What is secant the equivalent of if I'm talking about reciprocal functions? Folks from home, you're going to have to talk to me because Vanessa went to math.
1 over cosine.
1 over cosine, thank you. So 1 over cosine of theta. What's cotangent of theta?
1 over tangent.
So I could do 1 over tangent, or what else is cotangent?
Cosine over sine.
Good. So cotangent has 2 things, 1 over tangent and cosine over sine. The reason this time I would pick cosine over sine is because there's no other tangent in this expression. If there was a tangent in this expression, I would use tangent. But because this is already becoming a product of cosines and sines, I'm going to use cosine over sine times sine of theta. Now I can put sine of theta over 1 so that these are all in fraction form if that makes it easier. But what do we see that we can cancel here?
Cosine.
The cosines can cancel,
Sine over sine.
and the sines can cancel. So I'm left with 1 times 1 times 1 over 1 times 1 times 1. This is just 1. Which is as simple as it gets. All right, now go to 4. Cotangent squared of x times 1 plus tangent squared of x. As soon as you see those squareds mixed with a 1 or 2 things being added together that are squared, you want to go back to your Pythagorean identities. So the one that says tangent squared plus 1 equals secant squared. This time, I don't even have to rearrange that statement. This is straight up 1 plus tangent squared. So what can I put in its place?
Secant squared again.
Good. Now those are both reciprocal functions. So even though they're squared, I can write them in terms of their reciprocal functions. What's the reciprocal of secant? Good. So because it's squared, it would be 1 over cosine squared. And then there's cotangent again. And remember, you have 2 options. I can write it in terms of 1 over tangent, but that's not going to cancel anything out. Or I can write it in terms of cosine, and they would both get a squared. So cosine squared and sine of squared. Now what can we do?
Why would you get a squared?
Because they're both, this is squared. So that's like saying there's two cotangent squareds over, and so when we split it up, it'd be two cosines over two sines.
You can cross off the cosines.
Good. I can cross out the cosines. I get 1 over sine squared x. Can I make that simpler?
No. Cosecant.
Good. So you actually can, it makes it a reciprocal function, which seems like you're not simplifying it, but you're making it become one term instead of a fraction. So that is simpler. So I'm going to rewrite this as cosecant squared x. If you can get it down to one term, even if that one term is squared, that's as simplified as it gets. Questions on any of these four before we move on? Okay, this time it actually gives you a little bit of a hint, and it says simplify by factoring. So I'm going to look at 5 first. So if that didn't say factor, I would actually go to my Pythagorean identities, and I would see which one has a secant squared and a minus 1. But because it said to factor, we're going to factor this. So for some people, it's easier to use substitution and factor using a different variable. For example, if I said secant of x equals, like, let's say the letter a, then this would be a squared minus 1. And how could I factor that?
A plus 1, A minus 1.
Good, that's a difference of 2 squares. So instead of it being a, it's now secant. So it would be secant of x plus 1 and secant of x minus 1. That's all it wants you to do, just factor them. And again, before, like if it didn't say factor, I would actually rewrite this as just tangent squared, because that's a Pythagorean identity, okay? But this one said specifically to simplify by factoring. All right, go to 6. So I've got tangent squared, 4 tangent squared x plus tangent x minus 3. So I'm going to use the substitution again. I'm going to say this time the middle term, which is tangent, is my a. So if I rewrote this in terms of a, it'd be 4a squared plus a minus 3. Now it's been a little while since we've factored with 3 terms, especially with an a not being 1. So remember, you have 2 options. You can either do trial and error with the factors of 4 and then the factors of negative 3. Or we can do first and last. So I'd multiply 4 times negative 3, which is negative 12. Find the factors of negative 12 that sum to positive 1. Positive 4, negative 3. Substitute those in for that middle term. So 4a squared plus 4a minus 3a minus 3. And factor by grouping. First term, I could take out a 4a, and I get a plus 1. Second set, I can take out a negative 3, and I get a plus 1. Then the a plus 1s repeat. So I take that out and group together what's left. A plus 1 times 4a minus 3. But remember, a is not in my answer. Tangent is. So this would be tangent of x plus 1 times 4 tangent of x minus 3. Now, if you could do it without the substitution, you totally can, okay? It's just that for most people, it's easier to use that substitution. Questions? All right, how do we factor 7? See if we could do it without substitution.
One plus cosine x and one minus cosine x.
Good, different 2 squares again. 1 plus cosine of x, 1 minus cosine of x. And again, if it had said simplify, I would have just said that, so I would have rearranged sine squared plus cosine squared equals 1, and I would have gotten that that's actually sine squared. But because it said simplify using factoring, we did it this way. All right, 8, I would probably use substitution just because it's a little bit more complicated. A cosecant of x, and I get 2a squared minus 7a plus 6. You try it. Factor that out. All right, so this is what you should have gotten. Maybe the order is reversed, but the signs have to be the same, okay? So I made a cosecant of x, and I got 2a squared minus 7a plus 6. I made a cosecant, so I plugged that, then I did first and last. 2 times 6 is 12. Factors of positive 12 that sum to negative 7 or negative 3, negative 4. Plug those in the place, factored by grouping, and ended up with 2a minus 3 and a minus 2. And then you want to substitute back in your cosecant. Questions on that one? So I'm going to skip these ones for today, and I'll come back to them tomorrow. Wait for it, the next set. But I want to show you, hang on. I want to go over one of each of the next 2 examples. So if you're going to start the homework tonight, which I would obviously recommend because it's long if you wait till tomorrow, and we have bunches of time right now, I would skip the ones that have 2 different, like if something is squared and there are 2 different trig functions. We'll talk about this tomorrow. I'll show you how to do substitution with this tomorrow. Do you want to get to? I'll do one of each of these. So we're going to do 11 and 13. So look at 11 first. I've got a sum, and in the last ones we tried to factor something out, but can we factor something out of these? Is there a sign on both of them? No, right? There's not a sign on both of them. There's not a cosine on both of them, so I can't factor anything else out. What do you see there that you could replace? Cotangent. Cotangent becomes what?
Cosine over sine.
Good. Remember, it's 1 over tangent or cosine over sine, but there's no tangents here. So I'm going to make this cosine of x over sine x times cosine of x. Now I can simplify this term. Cosine times cosine would be cosine squared over sine of x. Now, I don't know if you remember, but I said at the beginning of the notes, there's going to be times in which we get fractions that we want to add together. So if I wanted to add these, I have to give them the same denominator. So sine x over 1 has to have what as its denominator so that we can add these?
Sine.
Good. So I'm going to multiply both the top and the bottom by sine, which makes this sine squared x over sine. So now my expression looks like this: sine squared of x over sine of x plus cosine squared of x over sine of x. The denominators are the same, so I can actually combine my numerators. Sine squared x plus cosine squared x over sine of x. Now be careful, because this is what you cannot do. Cross this out and cancel out one of those signs. You cannot cancel from the denominator into part of a sum, okay? You cannot do that, and that's something that a lot of people make the mistake of doing. But as soon as I see my squareds, I would go back to my Pythagorean identities, and one of them is sine squared x plus cosine squared x equals 1. So what can I replace that numerator with? Good. And what is 1 over sine x?
Cosine.
Close. Cosecant, right? Yeah, that's what you meant to say. Cosecant x. So this time we're writing cotangent in terms of sine and cosine. We're simplifying it. We had two separate fractions with different denominators. So we have to multiply by what we need to multiply by to get them to have the same denominators, and then add them. Okay, we're going to do one more and then we'll stop for today as far as notes go. Alright, so I get sine of x over 1 plus cosine of x plus cosine of x over sine of x. This is two separate fractions, right? I can actually simplify the right side and say it's cotangent of x, but then it's like a dead end. I get stuck there. There's nothing else to do there. So instead of doing that, I'm going to try to find a least common denominator so I can combine these into one. So I'm going to have to multiply both terms in the left side by sine of x. And I'm going to have to multiply both terms on the right side by 1 plus cosine of x. So my numerator becomes sine squared of x plus cosine of x, because I'm going to distribute this to 1 and to the cosine squared, plus cosine squared of x. So this is a 1 here, 1 plus cosine, and then I distributed that cosine to both. And it all goes over sine of x times 1 plus cosine of x. And I'm going to keep that separate for now. If I need to distribute later, I can, but I'm going to keep it separate for now. Now, do you see anything there that you can simplify? So I'll give you a hint. As soon as you see those squareds, you want to go back to your Pythagorean identities. So there's no Pythagorean identity that says sine squared x plus cosine. There's no Pythagorean identity that says cosine of x plus cosine squared. But there is one that says sine squared x plus cosine squared x, right? And I can rearrange this any way I want because it's all a sum. So I could do sine squared x plus cosine squared x plus cosine of x over sine of x, 1 plus cosine of x. And then what is sine squared of x plus cosine squared of x? Good. So sine squared x plus cosine squared x becomes 1 plus cosine squared x, just cosine, over sine of x times 1 plus cosine of x. Can I simplify that? So this whole thing matches this whole thing. I can't break apart part of it. I can't cross through the cosines, but I can cancel the whole thing out. And I'd end up with 1 over sine of x, which is what? Good. Cosecant of x. All right, so I'm going to stop from here for now, and then tomorrow we'll pick up with the right side of these. We'll do the last slide before this, and then the last slide of the notes. But my recommendation is that you look through the web assigned today and do as much of it as you can. So we've got a lot of it. We've got quite a bit of time. I think this class is supposed to end at 9:20 before math is over. So I want you to go ahead, and if you're a sophomore, they sent the link out. You obviously can watch math, but if you don't want to, or you're a freshman or a junior, you can spend this time doing that web assign. If you run into a question, please feel free to ask, because I'm obviously going to stay on with you. But I'm going to give you some independent work time.